Hello class, I wanted to make you a quick video tutorial to help with some of the questions for lab number 4 in investigating lunar phases. So with this lab, we're going to be using Stellarium again. So go ahead and pull up the Stellarium by clicking this link, and we're going to set our location again for being in Chandler, Arizona. Oops. Let's try that again. Arizona. Alright, we're going to use this location. Alright. Now we want to set the date to March 4th, 2025. So we're going to click that. To make this the 4th, 2025. Perfect. Now we want to set the time to be 12 o'clock noon. So we'll come down here. Oops, we were already there. I like to use this pause button to just freeze the time. That way it doesn't keep ticking away. We'll put this to 12 o'clock. 12 o'clock. There we go, 12 o'clock. Perfect. So now we're first going to look for the moon. Go. Perfect. So in this question number 2 of the lab, it is asking, is the moon ever above the horizon during daytime? So what we're going to do is just close that window, and we can see right here, here's the moon, and it is indeed above the horizon during the daytime. So we will just come here and we will say, yes. Yes, it is. So you will finish these questions. Next question we're going to look at is, how long does it take the moon to complete its cycle of phases? I decided to use this moon phase calendar because I found that doing this in Stellarium was really confusing. So I just switched it up a little bit, and if you click on this link, it'll bring you to this moon phase calendar, and what it's going to ask us to look at is the date of the first new moon starting in March. So we found when we click this link, it'll pull up March 2025, and what we're looking for is where the date of the first new moon is. So we can see right here that this is the date from the first new moon. It is March 29th. So we'll put this in here. 2025. So what the new moon is it is the very first day of the lunar cycle. You will see if you hover just above this that says new moon, it'll say that the age is 0 days, because that's the very first day of the cycle. It's also 0% illuminated. So what we're going to look for next is the date of the waning crescent. And that doesn't mean this waning crescent that's still here in this month of March, because this waning crescent is the very, very end of this lunar cycle. And you can tell when you look here, it'll say that the age is 28 days. So we want the next waning crescent. So what you'll do is you'll come here to select a month, and we'll just go into the next month, which is April. And we will look for the waning crescent. There are actually quite a few waning crescents. We want the very last waning crescent, which is the one that is right before the next new moon, where the age starts over. This is where the cycle begins again. So we want the date April 27th. So we'll just come in here. Okay, And then we're going to look at the age of the moon. So as we saw here, when you hover over the name of the moon, it'll show you the age, and the age is 29 days, so we're just going to put that here. Alright, and then it says to change the date to March 2026, and how you do that is you just come back up here to select a month, and when you scroll down, you can see that the year changes as you scroll. So you'll just change this to March and then start again. Alright, so there's one more question that I want to go over with you, because this one can seem a little confusing at first. It's really not too bad though. But we're going to be using Stellarium again with this problem. So what it's asking you are lunar phases related to the angle between the sun and the moon in the sky? Alright, so we come back to Stellarium and we have our time. It's already set at 12. We're going to first find the moon's phase percentage and then use this table to convert it to a phase name. And then we're going to enter that into column 2. So as you can see, I already did the very first one for you. I'll go over it with you right now though. So we're going to come into the date, and we're going to change the date in Stellarium to March 13th. So just going to move this to the 13th. Okay. We need to pull back up. We want to look at the moon. Alright. So we see right here is where we want to look for the phase. And for this particular day, the phase is 100%. So we come right here to this table, and we see that 100% is for a full moon. So we go ahead and come down and fill that into the table here. And the next value we're looking for is the moon's RA hours. So we come into this table, and we find RA right here. You don't need to pay attention to any of this other stuff, because all we're looking for is the hour. So this is the only value that you'll have to record. So in this case it's 11. We brought it down, put it in here. Next we're going to need the sun's RA hours. So come over here and we'll just look up sun. There it is. And again, all we need is the RA, so we're just looking for this value right here. And in this case, the sun's RA is 23, so we record that here. And then we're going to find the difference between the RA. So the difference in RA is calculated by subtracting the smaller RA from the larger RA. So when you subtract 11 from 23, you get a difference of 12. And this is a little note that I want you to pay special attention to, because this value cannot be larger than 12. If the difference in RA after you subtract the smaller from the larger is greater than 12, it means that the shorter path is actually the other way around the RA circle. This is because if you think of the celestial sphere as 360 degrees, anytime that we look at the horizon, we're only seeing 180 degrees of the sky. So if for some reason you've got a value that is greater than 12, then this is when you want to take your value that you found and then just subtract it from 24, which is how many hours there are in a day. I have a little example right here that might help make it a little bit more clear. This example also just so happens to correspond with this problem, so I'll go ahead and just go through this one with you. If we come over here and we look at March 22nd, we're still looking at the sun. So we're going to go ahead and record the sun's RA for March 22nd, which is 0 hours. Alright, so we'll come here. I'm just going to put 0, 0. Now we're going to go back and look at the moon for March 22nd. and the RA for March 22nd is 18. So we're going to come down here and put 18. Now you can see where this example kind of becomes clear, because when we take the smaller one and we subtract it from the larger one, we get 18, which is greater than 12. So what we want to do at that point is we take our answer, which is 18, when we subtract 0 from 18, and instead we subtract that 18 from 24, which gives us 6 hours, and that is the RA difference. Okay, so we put 6 right here. Might as well look at the moon phase too while we're here. So for March 28th, we see that the phase is 48%. So we're going to come right here to the table, and we are going to find that 48 falls within this section here, so it's going to be a quarter moon. So we will go ahead and type quarter in here. I am having a time with spelling today. There we go. Quarter. All right, and now for the, I already have it in there for you. Now for the last section, we're going to calculate the sun-moon angle. And the way you do that is explained right here. So again, when you think about the complete circle of the sky is 24 hours. And so when we divide each of the 360 degrees of the circle, it boils down to each hour equals 15 degrees. So all you really have to do is you take your RA difference found in this column here, and you multiply it by 15, and that will give you your angle. And in this case, it's 90. So that should hopefully help you get through all the rest of the assignment. Let me know if you have any other questions or you get snagged. I'm happy to help. Just shoot me an email and I'll get back to you as soon as I can. Okay, thanks. Happy researching.